Okay, guys, so now we're going to move on to test 8. If we were in class together, I would want to go over some of the harder ones with you, the ones that those might be newer concepts that we haven't actually reviewed yet. So I'm going to do that with us first. So here's the ones we're going to do together first. We're going to do 1, 6, 9, 10, 12, 13, and 16. And we'll go ahead and do those in order. So let's go ahead and do that. Then we're going to come back, and I'm going to do these in blue. These are going to be the ones I'd like you to try on your own. These may just be, once we do number 6 together, you should be able to try number 8. And number 11, I thought I had done, okay, so number 11, I don't know, I might do that one with you. Let's see how we do. Number 18 and number 20. And I may end up just doing them all with you. It might be the best way to handle this. Okay, so let's start with number 1. Number 1 says Karen left her house heading east, and her sister left 2 hours later heading west at a rate 5 miles per hour faster than Karen. 6 hours after Karen left, she and her sister were 600 miles apart. How fast was Karen moving? How fast? All right, so we notice, first of all, they're heading in opposite directions, right? Now, you have your test in front of you, so you can keep referring back as I'm going to do, but we're going to write out one of those diagrams that Saxon likes for us to use to help us get a picture of what's taking place here. So on your paper, I think I left you a big spot on your recording form for this. So let's say they're starting out in the same position. Remember, one is heading east and one is heading in the opposite direction. Karen was heading east, so we're going to call the distance of Karen over here and the distance of her sister over here. But the point is, we know that they're going 600 miles because it says 6 hours after Karen left, she and her sister were 600 miles apart. So their total distance is 600 miles. Okay, all the way. That's all the way over here and here. That's a 600 mile distance here. All right, so we know, and I'm going to write that off to the side, the distance of Karen plus the distance of her sister is 600 miles. Remember, distance always equals rate, whoa, where did that go? Times time. So I can actually re-express the distance of each one of these girls by saying the rate of Karen times the time of Karen would equal the distance of Karen. Plus, we're going to do the same thing for the sister. The rate of the sister times the time of the sister would equal 600. And we need to break it up like that because we're given certain parts to the equation or certain parts to the story, like we know the rate of the sister, we know the time of the sister, and we know the time of Karen. So we need to break it up. We need to take that distance and break it up into rate times time so that we can fill in some pertinent parts here. So off to the right here, a little bit further, I'm going to write what I know. I know that the rate of the sister, we were told, if you look back at the problem, it says the rate of the sister was 5 miles per hour faster than Karen. So she is traveling. So the rate of Karen plus 5 is the rate that the sister is traveling. She's going 5 miles per hour faster than Karen. That's the rate of the sister. We also know that the time of Karen, according to this, was 6 hours. And the time of the sister was 4 hours, which makes sense because she's traveling faster than Karen, so it should take her less time to get to wherever it is she's heading to. Okay, so now let's fill in what we know. So we're going to take this equation that we wrote just a moment ago, RK times TK plus RS times TS equals 600, and we're going to fill in this information from over here. Alrighty, so I don't have anything for the rate of Karen. We need that information at the end to help us figure out a rate. So we're going to leave that. That's what we're going to solve for. The time of Karen was 6. The rate of the sister, we know, is what we wrote over to the right, RK plus 5. And the time of the sister is 4, equals 600. Now let's go ahead and solve that. If you want to pause the video to see what you get for the rate of Karen, and then come back and check it with me, that would be great. I'm going to keep on moving, and you can check it when you're done. And I'm just being quiet for a moment because I'm just going to work through the problem. Okay, so as you can see, I simply put together my like terms. I had to use some algebra to balance my equation by right here where I subtracted 20 from both sides. I just worked it all the way down to the end, and I found out that the rate of Karen, in other words, what was her speed, how fast was Karen moving, was 58 miles per hour. And that is the answer to number 1. Now let's look at number 6. Number 6 up here. Okay, so that's number 1. Let's move down to number 6. 20xz minus 2x squared z minus 42z. Alrighty, so I'm going to go down here below, and I'm going to write out the problem, and then we'll solve it together. Whoops, not 2. 6. It is the second one I'm going to do, but it is not number 2. Alrighty, so we have 20xz. And if you guys would get in the practice of, if you write a z, and maybe you already do this, but if you don't, could you make your z's with a little line through them so that when I'm grading, I don't have to stop and think, is he writing a, or she writing a z or a 2? So just be cautious of that if you would. That would be helpful for me. Okay, so we want to factor out. Number 6 tells us that we are to factor completely. We're always going to wants us to factor out the greatest common factor as the first step. So we look at our terms and we try to identify, what do all 3 of these terms have in common? Well, I see that I could actually factor a 2 out of each one of those. I could also factor out at least one x and one z. And that's all that I see that I could, hopefully you're going, no, Mrs. Quigley, no. I cannot factor out an x because negative 42z does not have an x. So the only thing I can factor out is a 2 and a z. Now we're going to put in parentheses what remains. And remember, whatever I put in parentheses, to check it, to make sure we've actually done it correctly, we can actually in our heads just redistribute it and see if we come back to our original equation. Let me show you what I mean. All right, so the 2z, I have to multiply with 10x in order to come back to this first term up here. So if I multiply this, I'm going to get 20xz. Is that my first term? Well, yes, it is. So I've done that one successfully. We're going to work that through just like that all the way through. The next part of this is going to be, I need this to be a negative 2x squared z. So what would it take to do that? I need an x squared, and that is all. And because see, if I redistribute that, I'm going to have negative 2x squared z. And that's what's here, negative 2x squared z. Remember, this is the negative sign that's attached to that term. And then finally, for the last one, we are going to have 21. If I multiply 2z times negative 21, it's going to give me that negative 42z. Okay, so I factored it correctly. Now, I'm going to rearrange my trinomial. This part right here, I need to rearrange it in descending order of its exponents. So I'm going to keep the 2z on the outside. I'm going to move the negative x squared here, plus 10x. Remember, move your signs with the numbers it's attached to. Okay, now we know that I cannot have a negative x squared. I need to not have that. So I'm going to multiply the entire thing by negative 1. everything. So I'm going to write it on this side too, just so we don't forget. So that's going to give me a negative 2z here. And if I multiply negative 1 by every term in that trinomial, I'm going to end up with a positive x squared minus 10x plus 21. Okay, perfect. All right, now I'm going to keep my negative 2z as it is, and I'm going to factor that trinomial into 2 factors. And remember, we talked about this. I love this method. Let's see if we did this now. I'm going to take 21, if I can remember correctly. Let me think. No, 21, right? And negative 10, I think is what we said. Is that what we did today? I should have written it on my paper. Well, as I work through this, I'll see if that works out. Yes, I think it does. Okay, so I'm looking for factors of 21. So if I list the factors, I would have 21 times 1. But if I add those together, there's no way that can give me this negative 10 down here. Okay, so I think this is what I was trying to say in class today. This is the product, and this is the sum. I think that's what I was trying to remember today. Okay, so how about 3 times 7? If I multiply 3 times 7, I would get 21. How could I get negative 10 when I add those two numbers together? Well, if they both were negative, I could get a negative 10. Well, how about if I multiply negative 3 times negative 7? Does that give me a positive 21? Yes, it does. So those are actually the numbers I'm looking for. So it would be x minus 3 and x minus 7. And that would be your final answer here. Okay, so that is number 6. Let's bump down to number 9. Number 9, we're going to simplify this little mess here. We have PM minus 3p squared m to the third. And if you want to pause the video and try this on your own, you certainly can. Let me get you started. You're going to try to factor out the greatest common factor in your numerator, and that might allow you then to do some canceling between your numerator and your denominator. If you would prefer to watch me do this and walk through it with me, that's completely fine as well. So I'm going to look at the numerator, and I'm going to determine, do each of these terms, this one and this one, share anything in common? It looks like they both have a p, and it looks like they both have an m. So let's pull out pm, and the rest of it's going to go back into the parentheses. So what would it take inside my parentheses that when I distribute that will bring me back to that original PM over here? Well, really, the only thing that would work is a 1, right? PM times 1 would bring me back to that PM. Okay, so we're going to keep that 1 in there. We know it's going to be a subtraction. And what would it take to get me back to 3p squared m3? I would need to put my 3 in there. I would need to put another p and 2 m's, right? So if I were to redistribute this, I would have negative 3p squared m to the third power, which is exactly what that second term was. Okay? All of that over pm. Oh, isn't this beautiful? Look what happens. I can cancel this. So my final answer to this problem would be 1 minus 3pm squared. And that's how you do number 9. Now let's look at number 10. Number 10, I love these problems where we have the square roots. When you have, in order to simplify this, that means that we want to get that square root out of the denominator. So how would I do that? Well, the only way I can think of to do that would be to multiply by the square root of 5, right? Because if I multiply this square root of 5 with the square root of 5, remember what we're going to get? 5, because the square root of 5 times the square root of 5 is the square root of 25, which we know is 5. Remember we talked about that the other day, that when you multiply two square root numbers together that are the same number under that radical sign, then you would be able to just pull that number out. But remember, if I'm going to multiply my numerator by the square root of 5, in order to keep this thing in balance, I have to multiply the numerator with the same square root. All right, so I'm going to end up with 5 times the square root of 5 over 2 times 5. So I'm going to have 5 times the square root of 5 over, oh, wait a minute, before I do that, look here, I can cancel those two 5s, can't I? Because these are factors, and I can cancel when we have factors. All of that over 2. So I need to get rid of that 5. Let's see here. There we go. So you're going to have the square root of 5 over 2. Okay, now if you don't see what I did there, you could simply say 5 times the square root of 5 over 10. And then you're going to see this is 1 and this is 2. And you get the same thing. Okay, so either way you like to do that. I like to do the canceling because it just gets rid of a bunch of stuff quicker. Okay, let's now look at number 12 together. Number 12, on your test, we are supposed to simplify. Okay, now I have actually seen these as far back as in the 8-7 book of Saxon. So maybe some of you will be like, oh, goodness gracious, I know how to do these. These are called complex fractions, and we have 2 fractions within one fraction. So your numerator is a fraction, obviously, and so is your denominator. So in order to eliminate this denominator, I want to end up with a 1 in the denominator. So how would I do that? Well, I could multiply by the reciprocal here. But remember, again, there's a rule about multiplying in a fraction. If you multiply the denominator by some value, then you need to do it up top too. Because remember, those two together, x over c over x over c, all of that is 1. Okay, but now look what happens. So I'm not changing the value of my fraction by multiplying that. But look what happens. These will cancel out. And now I'm going to end up with a plus b over x times x over c. But remember, when you're multiplying with fractions, I can cancel anything as long as these are factors. I can do some cross-canceling here. My x's are going to go away. So I'm going to end up with a plus b all over c. And that's the answer to number 12. Let's look at number 13 together. Number 13 says they want us to add together these 2 ginormous fractions here. So let me get this written out. Let me make this a clean sheet. 13, we have 3x over x squared plus 3x minus 10 minus 4 over x plus 5. All right, so I'm going to kind of evaluate what I've got going on here. I see a trinomial in my first fraction. I have x squared plus 3x minus 10. So I'm going to do that method with the x here. So I'm going to have a negative 10 here and a positive 3 here. So I'm looking for factors that would satisfy the negative 10, that when they are addends, they satisfy the positive 3. So what are the factors of 10 that I could use here? I'm going to think about 2 and 5. Well, if I multiplied those together to get a negative 10, one of them must be negative and one of them must be positive. But when I add them together, they have to be the positive 3. So that means that my 5 would have to be positive and my 2 could be negative. So I'm going to rewrite down here the denominator here for that trinomial, as I factored it. And it's going to be x minus 2 and x plus 5 minus 4 over x plus 5. Now my denominators are not the same and I need for them to be. So what is lacking? Well, on this side, I have part of this. I have that part, but I need this part. So I am going to put that into the denominator here and also into the numerator here. Right? Whatever I do to the denominator, I must also do to the numerator. And now I can simply put these together because I have the same denominator. So I would have 3x minus, I'm going to put these in like so. Remember that this is going to affect everything. So I'm going to have 3x minus 4x plus 8. Right? Because this is like having a negative 4 out here. Let me kind of do this. See if I can get in there. So that minus sign over here is looking, I'm going to actually move it closer. Let's see if I can get this closer so you can actually see what's happening here. 3x minus. So I have a negative 4 that when I distribute it would give me a negative 4x plus 8 all over x plus 5 times x minus 2. And that is your simplified answer of putting those two fractions together. Oh, wait a minute. I got to go a little bit further. Let me see here. Oh, goodness gracious. And hopefully, again, I love it when you guys can catch me in things because that tells me, first of all, you're being good mathematicians when you do that. I'm the teacher, yes, but I still make mistakes too. My brain gets tired sometimes of doing numbers just like yours does. So sometimes I'm going to be making a few little flaws, and I love it if you can catch me. So hopefully you did. So I notice here that I have x terms that I can actually put together here. So 3x minus 4x is a negative x plus 8 over that big denominator, x plus 5 times x minus 2. Now, if you caught this early enough, we don't usually like the negative x on the outside, so you probably would turn this around to say 8 minus x, and then put that denominator down here. And if you caught that before this last step and wrote it over here, that's fine. But this would actually be your fully simplified answer. Okay, so that's number 13. Now let's look at number 16 together. And this is a little bit longer of a problem. You have your test there. I'm going to take a look at it on mine as well. Number 16. Okay, we did one of these in class on Thursday where you had overlapping triangles. So in this case, we're going to look for M, N, and P. So I'm going to actually redraw this out, but what I'm going to do, look up here. I don't want to make you dizzy, so I'm going to try to go a little slow. I'm going to actually pull these out like I did today. Okay, so I'm going to make two triangles. I'm going to make the little guy that looks like this. We know this is 6, this is N, and this is M. And then you have the big guy. And you have N plus P for the hypotenuse. You have 9 for the bottom, and you have 14 for this side. Okay, so I'm going to just try to write everything up here. So we're going to look at step 1. Step 1, we're going to set up a proportion wherever we can. And I see if I find corresponding sides here, that's one side, it corresponds with this side. Okay, it's the leg on the left-hand side. So I can write a proportion with that by writing it as a fraction. 6 over 14 equals, and then find another set of corresponding, let me find something different here. We'll take pink right here. The base of that triangle. I'm going to set it up in the same order as I did 6 over 14. So 6 is from the small triangle, so M has to be on the top and 9 on the bottom. Now I can solve this thing by doing cross products. And when you do that, you're going to end up with M equals 27 over 7. Okay, so that's M. I'm going to box that in. That's one of the answers. Step 2, I guess I'll go below it here, and I'll do it in a different color. We'll use green. For step 2, we're going to use, I want to keep saying the quadratic formula, but that's not right, the Pythagorean theorem, which means we take both of the legs and we square them and add them together, and that's supposed to equal the hypotenuse squared. So a squared plus b squared equals hypotenuse squared. But in this case, we're going to use m squared. Let me show you how we're going to write this out. We're going to go m squared plus 6 squared is going to equal the hypotenuse squared. Why do I pick that? Because now this is all off of the smaller triangle. And I'm using the smaller triangle, and I can actually make a little note here. Small triangle. I'm going to use those parts because it'll be easier for me to solve for n. I know what m is already, so let's just fill in what we have. So we're going to have 27 over 7 squared. That's m squared for my smaller triangle. And then I'm going to do 6 squared, which was coming off of the smaller triangle as well, would be 36, equals n squared. So you see, we're going to be able to isolate n and solve for it. My power is going in and out. I hope I don't lose Wi-Fi. I guess it won't matter. I think I'll be okay. Okay. All right, so when I do the math here, 27 squared is 729 over 49. And if I change 36 to something over 49, it's going to give me this great big ginormous number, 1764 equals n squared. Gracious. Okay, put these together. You're going to have 2493 over 49. If I take the square root of everything, you can see the denominator there lends itself to a nice 7. At the top, we're going to change this 9 times 277. So you're going to end up with 3 square root times the square root of 277 over 7 equals n. Isn't that a crazy number? But that's what n is. So we managed to get n. I'll check it off. And now to find p, okay, I'm going to find yet another color. This is going to be step 3. And we're going to use the large triangle. And we're going to use the same method that we did in step 2. We're going to use the Pythagorean theorem, and we're going to take our 9 squared plus 14 squared equals, right, because here's 9 squared plus 14 squared. There's the other leg. And this is the hypotenuse right here. It's always across from the right angle. And so that side is going to be p plus n squared. All right. So we have 81 plus 196 equals p plus n squared. This is going to get lengthy. If I can't fit it in here, I'm going to probably have to, I might be able to. All right, so I'm going to have 277 here equals p plus n squared. And then I'm going to take the square root of both sides in order to undo that exponent of 2. Remember, if something is squared, then I can take the square root of it. So I'm going to have p plus n equals the square root of 277. The nice thing is that I know what n is equal to, right? Because we found that right over here. So I can now plug in n. So I'm going to have the square root of 277 equals p plus this crazy number, 3 times the square root of 277, all over 7. But isn't this nice? Do you see what's happening here? And actually, I think what I'm going to do at this time is, let me see here. Oh, I guess I'll just leave it as it is. Okay, so I want to isolate p Actually, what I'm going to do is I'm going to come up here and finish it because I don't want to run into that problem below there. Okay, but I'm going to flip this thing around so P is going to be on the left-hand side. I'm just going to turn the whole equation around. Don't be alarmed that I'm doing that. That's legal. Oops. Okay, now I can subtract this term right here. From both sides. I'm going to draw a line here so it doesn't get so busy. Times the square root of 277 over 7. These are going to cross out. I'm going to have P equals, trying to see something here. If this was over 1, and I need to make it 7, right? Because I need to subtract these two right here. I need to subtract those two. And I don't have the same denominator. So I need to change that top one to give it a denominator of 7. So we're going to rename it as something over 7. So I have to multiply the top by 7. So it's just going to be 7 times the square root of 277 minus, this is turning out to be really nice. I know you don't think so, but it is. Because look, they have the same denominator, and they both have the same term. They both have the square root of 277. And when you think of that as like an x term for just a minute. Think of it as P equals 7x over 7 minus 3x over 7. It'd be like having x terms there. So we can put those two together. So watch how that ends up. So P is going to be equal to, we subtract like the coefficient number there, the 7 minus 3, and you're going to get 4 times the square root of 277 all over 7. And that is an even crazier number than what we found n to be equal to. So P is going to be equal to 4 times the square root of 277 over 7. That's a lot of work, but there's P. So we found all three. If you need to screenshot that or go back and watch it, pause it, whatever you need to do, feel free to do that. Those were the ones I would have done with you in class. If you want to stay tuned for 8, 11, 18, and 20, I'll go ahead and do those. Otherwise, you can pause the video and come back and check your answers. You're welcome to do that however it works best for you. So number 8, I'm going to write it below here. Number 8, right here. We have 63a squared xy plus 9a squared x squared y plus 108 a squared y. Number 8. And we are going to factor these out by finding the greatest common factor. So what do they all share is what you're looking for here. Well, it looks like 9 would go into every single one of these. So let's pull out the 9. What else? They all have a terms. Actually, they have a squared terms. They don't all have an x, do they? The first two do, but the last one does not have an x. They all have at least one y, and that's it. So let's put back into our parentheses what needs to remain. So in order to get that 9a squared y back to this first term, we would have to multiply it with a 7x. That would give us 63a squared xy. The second one here, let's look and see what would get us back to this. Well, we have a 9a squared y on the outside, so I would need x squared is all, right? So if I redistributed this, I would have 9a squared x squared y. So that gets me back to that second term. What about the third one? What would I need in there? Looks like if I just multiply it by a 12, and that's it, because that would give me 100a squared y. So that takes me back to my original term. So there, we've successfully done factoring. Okay, now I'm going to look at my trinomial that's inside the parentheses. A trinomial, because it has 3 terms, I'm going to leave what's on the outside alone. I'm going to rewrite it, though, because I want to make sure that I can follow what I did. If I have questions about if I make a mistake, listing the steps will help you find your mistake. Let's put these in order, in descending order of the exponents. So I would have a positive x squared plus 7x plus 12. Okay, and then I'm going to rewrite this little mess down here. And we're going to factor this into 2 factors using our little method that we love so much. We're going to put a positive 12 here, and we're going to put a positive 7 here. This is going to be the product. So what am I going to get? What are the factors I'm going to pick? The factors of 12. Let's try 3 and 4. So 3 times 4 is 12. They have to total to give me the sum of positive 7. So they both have to be positive, don't they? So I'd have x plus 3 times x plus 4. And that's the answer to number 8. Let's look at number 11. Number 11, I'd love for you to try this one on your own and see where you land. This one is going to be where we're going to simplify some more square roots here. So we have 3 times the square root of 27. If you need to watch me through this, you can certainly stay tuned, or if you want to pause the video and give it a shot on your own, feel free to do that. Okay, what we want to do is notice what's under the square root sign. I have the square root of 27. That would break up into 3 times 9, and I want to do that because I'm thinking all the time, how can I break that bigger number into factors that would be a perfect square? Well, 3 is not a perfect square, but 9 is. So I'm going to be able to get that outside that radical sign under there. Okay, so let's look at the next one. What does 108 break up into? Well, I can think of a few perfect squares. If I did a 9, I know that 9 times 12 is 108. I also know that 12 can actually be broken up into 4 times 3. So I have 2 perfect squares under there, don't I? The 9 and the 4. And let's look at the last one here. We know that 75 can be broken up into 25 times 3, which is perfect because the square root of 25. 25 is a perfect square. So let's pull out now what we have. So the square root of 9 would be 3, so we'll pull that out and we'll leave the 3 underneath there. Then we're going to come over to this one. Whoops. I don't want to do that yet. And we're going to pull out the square root of 9, which is 3, the square root of 4, which is 2, and we're going to leave the square root of 3 under here. And I can see where this is going to land us. This is going to turn out to be a beautiful thing. We're going to keep the 2 there, and then we're going to take out the square root of 25, which is 5, and leave the square root of 3 alone. So let's do our multiplication now. So I have 9 times the square root of 3, minus 4 times 3 is 12, times 2 is 24, right? That's all of this, times the square root of 3, minus 10 times the square root of 3. Now, because they're all being multiplied with the square root of 3, I always like to think of these like this, like as an example. Don't write this. I'm just saying. It's almost like they have the same term here. It's like they're all x terms, but they're not x terms. They're like square root of 3 terms. Okay, so I can actually combine those like this. So I'd have 9 minus 24 minus 10. You're going to end up with a negative 25 times the square root of 3. 9 minus 24 minus 10 would be minus 25 times the square root of 3. And that's the answer to number 11. Let's look at 18 together. Okay, 18 is a little long, but you still might be able to try this one on your own if you'd like. I always encourage you to do that just to see if you can get the right answer. I like when I see anything to the 0 power because that's going to simplify so nicely into a 1. Whoops, get back here, you. It like gets rid of a lot of stuff quickly. All right, so let's take care of what we can here for number 18 right up front. I noticed that I'm going to leave my negative 3x alone. I'm going to go ahead and I'm going to change the 5 to the 0 power to a 1 minus x over 2 plus x plus 1 over 3 equals 4. Now, I don't want you to be alarmed with what I'm about to do. This is what we did on one of the problems from test 7 during class yesterday. Okay, if you recall, we were trying to, instead of making common denominators, we want to clear the denominators. They call that clearing the fraction. So I want to get rid of the denominators quickly and easily. So what I'm going to do is I'm going to figure out what would be the common denominator. Hopefully, you can see that it would be 6. So I'm going to use that 6 to my advantage by multiplying every term. So I'm increasing everything by 6. I'm going to multiply everything by 6 because that's going to allow me to cancel the denominator. Watch how. So I see 2 here, and I can say, so this would become a 1, or in other words, it would just be gone, right? And then I would have to change this to a 3. Okay? Yes, this is going to get a little busy, but watch what happens. Once you get used to this idea, you're going to really learn to like it. Okay, so I'm going to do the multiplication of my first term here. It's going to be a negative 18x. And then I'm going to have minus, I've got that 3. So I'm going to rewrite this so you don't get lost, okay? Minus 3 times 1 minus x. Okay, remember that 3 up here. I can't just throw it away. It's right there. I just highlighted it in yellow so you can see it. Okay, and that's what I put right here. So 3 times that quantity of 1 minus x. Plus, and I have this 2 over here. Let me highlight that one in pink. 2. And I'm going to put that 2 right down here. So we have 2 times the quantity of x plus 1. Okay, so you can kind of see where I'm getting all this from. Equals 4 times 6, which is 24. So it kind of simplifies it out really nicely already. So let's do some distributing. Negative 18x minus 3 plus 3x. Remember, this negative, I'm going to move him over a little bit, is like attached to that 3. Okay, negative 18x minus 3, but that minus sign is like acting like a negative sign on that 3. So you're distributing negative 3 inside here. Okay, plus 2x plus 2 equals 24. Now you could probably pause the video, combine your like terms, and figure out what x is equal to, and come back and see if you got the right answer. And I'm going to go ahead and finish working through this. So I've got some x terms here that are going to give me negative 13x. And then I have some constant terms here, which is going to give me negative 1 equals 24. We add 1 to both sides. And that's the answer to number 18. And then the last one we're going to do together is number 20, and this should take care of all the ones that were assigned. All right, number 20, I'm going to go up here and look at it with you on the test. All right, because they give us this diagram over here. It looks like 2 semicircles. Looks like owl's eyes is what I see when I look at that picture. And what we want to do here is notice we have 2 semicircles and we have a right triangle all combined into one diagram. They're telling us that this is the base of a cylinder. Okay, so it's a really odd shaped cylinder. But if you had a can of Pringles, it's almost like having a half of a can of Pringles together with the other half. Okay, so envision that. Or you had a can of Pringles that you cut all the way down from top to bottom, and then you opened it up where you could like make this little triangle. I don't know if you can see. I wish I was with you so I could show you that. But anyway, here's what we need to do. So we want to find the lateral surface area of the cylinder. Okay, so the lateral surface area, oh, how I wish we were in class together so I could show you this. Let me just kind of I am going to draw a Pringles can here. Okay. The lateral surface is only the surface that is around the can. It does not include your bases. If they wanted the area of the bases, what they would ask you for here would simply be surface area. But they only want the lateral surface area. So they're only asking for, on the cylinder, they're only asking for that which wraps around the shape. Okay, they don't care about the bases. All right, so we have to know how to figure this out. If I was with you and I could show you this, I want you to think about a can of Pringles again, or a soup can. A soup can might be more realistic because it has an actual label that I can actually slice down and take off. So think about that. When I have a soup can, if I take the label off and I lay it out flat, think about what that's going to become. It's not a circle, is it? It's actually a rectangle. It'd be like taking a piece of wrapping paper and wrapping it around a can. It would be a rectangular piece of wrapping paper first, and then you would wrap it around the can. Okay, so in order to find the lateral surface area, I need to know the length and the width of that rectangular piece of wrapping paper. Okay, now in this, so I would just figure out when I took it off, I could measure the top and I could measure the height. Okay, so the height is very important. And by the way, let's see, the base of an 8 meter tall. So here, see, we're already given the height right here. All right, this is the base over here. Okay, so it's not like it's a rectangular shape, but what it is still a base. And I want you to think about, how would I figure out if I could take it apart? It's kind of hard to explain without seeing me, I think. So I guess what I'm going to have to do is go back to the can of Pringles just to kind of make it clear. If I knew the perimeter of my can around, then I could figure out my lateral surface. It's just taking the paper off. So in this odd looking shape over here, if I know the perimeter of this thing and I multiply it with the height, then I can figure out what the lateral surface area is. Okay? So let's figure out, I'm going to get rid of this guy because he's just in my way. And I might, if I can remember, I'll do this illustration with you. Maybe you can remind me. And we'll probably see more of these as we practice anyway. But here's how you figure the lateral surface area is always figured like this. So please write this down. It is the perimeter of the base. Okay, and they are giving us the base over here. They're telling us that's the base of our prism, our cylinder. So the perimeter of the base times the height will tell you the lateral surface. All right, so how do I figure the perimeter? Well, I have this one here, 11.3, but I don't know that part. Well, what is that? Those are semicircles. So if I can figure out the circumference, right? Because the circumference is like the perimeter of a circle. It's the measurement around. So circumference and perimeter are really the same thing when we're referring to a circle. And what was the formula for the circumference? The circumference is 2 pi r, or 2, you might have seen it like this, pi times diameter. But we'll use the 2 pi r on this one since we have the radius given to us. Now I could do this one of two ways. I could actually think about putting that circle back together and getting the whole circle's circumference by putting this circle and connecting it with this circle, then I have a full circle. Since they both have a radius of 4, that would be safe to do. Okay, but if you don't, then we know that to find a semicircle, we would have to divide that by 2. Okay, but you'll have to remember, I have 2 semicircles, so then I'd have to multiply the whole thing by 2 anyway. So let's find the perimeter of the base. So what I have is I have 2 semicircles, and they are going to be 2 pi r. Since it's a semicircle, we'll go ahead and divide it by 2. But watch this. There are 2 of them. So this is 2 semicircles is basically what I just figured up there, plus that other part on the top, which is the hypotenuse of that. You can see the triangle in there. That's the hypotenuse of the triangle is 11.3. So here's what we're going to figure out. And the height then is 8. In the problem, it tells us that the cylinder is 8 meters tall. Okay? So there's our equation that we're going to solve. Hopefully I have enough room that I can do it right here. Alrighty, so here we go. I can cross out these 2's. I'm going to end up with 2 pi r, but I'm going to put something in for the r. I'll use pi as pi for just a moment, and the radius was 4, right? So we'll put a 4 here, plus 11.3, and all of that gets multiplied with the height, all of it. Okay, so what do I have here? I have 8 pi plus 11.3 times 8. I'm going to go ahead at this time and I'm going to put 3.14 in for pi. So I'm going to have 8 times 3.14 plus 11.3, and all of that is going to be multiplied by 8. Excuse me. 8 times 3.14, if you put that in your calculator, you should get 25.12. We're going to add that to 11.3. Again, this is all going to be multiplied by 8. I'm going to carry the 8 right along with me because I don't want to lose sight of it. Just going to continue this right over here. 25.12 plus 11.3 is 36.42. Multiplied with the height of 8. In your calculator, you should get 291.36 meters squared. That, my friends, is the lateral surface of that interesting shaped cylinder. It's not a nice cylinder like a can of Pringles. It's got an odd shape to it. But that would be the lateral surface. We don't care about the base. We don't figure out the area of the base. We did need to know some information about the base, though, because we needed the perimeter of it. Okay, so that's how you do number 20. If you have questions on that, you can hold those for me for next week. I'll be happy to go over those with you. I hope that this was helpful for you all. I know it was a bit long. It was like sitting in class with me. But hopefully it was helpful. And I guess I just want to thank you for sitting through it with me. And I will see you guys next week. Have a great weekend, everyone.